Okay, so here we will see the relation between sequent depths. Okay, in last video it was left halfway, but here we will complete it. So supercritical side, subcritical side, the flow takes place from left towards right hand side. So consider a jump on horizontal floor between 1 1 and 2 2. So this is section 1 1, section 2 2. P1, Y1 and V1 are the respective quantities, velocity, pressure and depth before the jump, whereas P2, V2 and Y2 are the quantities after the jump. Okay, so by continuity equation, Q discharge is equals to by1 v1 is equals to by2 v2. Okay, so b into y1, this is nothing but the area. So a1 v1 is equals to a2 v2, like this. B into y1, this is area. Okay, breadth into height, so a1 v1 is equals to a2 v2, like that. It is b1 y1 is equals to b2 y2. B is width. Now discharge per meter width, or unit discharge. So as I told you, its width is b, so total discharge is q. Q divided by b will be discharge per unit width. So small q is equals to capital Q by b, and capital Q by b, so this is equals to v1 y1 is equals to v2 y2. So, okay, I think it's clear now. So v1 y1 is equals to v2 y2. So from this we can find out v1 as q divided by y1 and v2 as q divided by y2. Okay, now consider the unit width of the channel and consider liquid mass between 1 1 and 2 2. Okay, so applying momentum equation between section 1 and 2. So sum of forces in direction of flow is equals to rate of change of momentum. This is simply momentum equation. Sum of forces in the direction of flow. Okay, so the forces considered are P1 minus P2. P1 is in forward direction, P2 is in reverse direction. Okay, why so? So P1 is in forward direction in the direction of flow, and P2 hydrostatic pressure is in the backward direction. Okay, P1, P2. Okay, but no other force is considered. Have you noticed this other than P1 and P2? Why so? Because our assumptions state like that. So the component of weight in the direction of flow is 0, etc., etc. Those assumptions are there. So finally what we assume that other than hydrostatic pressure, there is no other force acting there. Okay, and this is equals to change in momentum. Momentum is change in velocity divided by multiplied by mass, gamma into q divided by g. So now hydrostatic force P1 is equals to a gamma a1 x1 bar. Okay, so this comes out to be gamma a1 is y1 into 1. So, width is 1, b is 1. Okay, and x1 bar, this is actually y1 by 2. How it comes to be? So it's a rectangular flow, and for rectangular section we know the CG is at a half of the height. Shall I draw a small diagram here? If suppose this is one such a rectangle having height y, okay, so CG is here, okay, at y by 2. Okay, so if this is y1, then this will be y1 by 2, height of the CG. So ultimately it is gamma y1 bar by y1 square by 2. This is for P1. Similarly for P2, gamma y2 square by 2. Okay, so V2 minus V1. Okay, V2 minus V1. Sorry, this P1 minus P2. So P1 minus P2 is this. gamma y1 square by 2 minus gamma y2 square by 2 is equals to gamma into q divided by g into v2 minus v1. Okay, so this is y1 square minus y2 square. Okay, now v2 is equals to q by y2. Okay, and v1 is equals to q by y1. This we know, we saw in in the beginning. Okay, so y1 square minus y2 square, this, okay, is equals to 2q upon g into bracket q by y2 minus q by y1. Okay, so breaking this, a square minus b square, its roots are a plus b, a minus b. So y1 plus y2 in one bracket, y1 minus y2 in another bracket. 2q by g as it is, q taken outside, now this becomes q square. Okay, 1 upon y2 minus 1 upon y1. So y1 minus y2 upon y1 y2. Okay, so and this y1 minus y2 and this y1 minus y2 get cancelled. Okay, so y1 plus y2 is equals to 2q square by g as it is, और bracket में जो रहेगा y1 into y2. Okay, now so remember this equation, this is very useful. Y1 plus y2 is equals to 2q square divided by g y1 y2. Now multiplying the above equation by y2, what we get, y2 square is equals to y1 y2 plus 2q square divided by g y1. Okay, we have multiplied by y2, so y2 y2 get cancelled. Now dividing this by y1 square, so y2 by y1 bracket square plus y2 by y1 is equals to 2q square upon g y1 cube. Okay, but this q square upon g y1 cube is, we know, we can write it like this, 1 upon g y1 into bracket q square by y1 square. So q square by y1 square is nothing but v1 square, so v1 square upon g y1. Okay, so q square upon g y1 cube is equals to v1 square upon g y1. Okay, so this is equals to v1 divided by square root of g y1 bracket square, this you can write like this. Okay, and v upon square root of g y1 is nothing but Froude number, velocity divided by square root of g into y1. Okay, so this is Froude number. So ultimately what you get is like this, y2 by y1 bracket square plus y2 by y1 is equals to 2 fr1 square. Fr1, this is to indicate it is Froude number before the jump. Okay, next y2 by y1 bracket square plus y2 by y1 is equals to 2 fr1 minus 2 fr1 square equals to 0. Now this, I'm just forming a quadratic equation, nothing else. Okay, now solution to the above quadratic equation is given by, so it is quadratic in y2 by y1. Okay, so it the solution is given by minus b plus or minus b square minus 4ac, square root of b square minus 4ac upon 2a. Okay, so you can write it like this, my y2 by y1 is equals to 1 by 2 into bracket minus 1 plus square root of 1 plus 8 fr1 square. Okay, so you can write it for y2 as y1 by 2 into bracket minus 1 plus square root of 1 plus 8 fr1 square, and you can now find out y2 if you know y1, or you can find and y1 and fr1. Okay, now similarly when we multiplied here this equation, dividing it by y1 square, now if we divide it by y2 square, okay, we can get another equation. Okay, and it will be like this, y1 is equals to y2 by 2 into bracket minus 1 plus square root of 1 plus 8 fr2 square. Okay, so here we can find out y1 from y2 and fr2 square. Okay, anyway y1 y2 you can find out. Which equation to be used is depends on whether fr1 is given to you or fr2 is given to you. Okay,